Hello, everybody. And today I'd like to go over a very recent but significant finding in the field of psychology today. The implications of this finding have a wide variety of applications that play a big role in normal life, abnormal life, understanding attention, understanding the brain, and understanding ourselves. This finding I'm referring to is the default mode network, and it is believed to be the neurological basis for our sense of self. It's a network that's active for the majority of the day for just about everybody, and hopefully not for some of you right now. The default mode network is a network of interacting brain regions that are active when a person is not focused on the outside world. It's active during a baseline period of rest, which is why it has the name the default mode network. It plays a role in the processes involving thinking about the self, thinking about others, remembering your past, and envisioning the future, amongst other things similar in content. It could also be referred to as the medial frontal parietal network, and it is also active during passive rest and mind wandering, such as daydreaming. This network of brain areas is involved in internally directed thoughts and is suspended during specific goal-directed behaviors, which is how it was found. It was observed when researchers noticed that their subject had a higher metabolic rate in the brain whenever they were at a passive rest, and a decrease in metabolic activity whenever they were engaged in a goal-directed behavior, such as solving complex math equations. Whenever one is engaged in a goal-directed behavior, something called the central executive network turns on and the default mode network turns off. And these two networks are anti-correlated, with meaning that when one network is turned on and the other is turned off, but this switch between the networks happens really fast, with the default mode network resuming function within fractions of a second after a task has been completed. This network of brain areas has been a prominent area of study since its discovery in the late 90s and the early 2000s. And before 2007, there was only about 12 papers published that referenced the default mode network in the title. But between 2007 and 2014, the number of papers published about the DMN went from 12 to 1,384. Part of this huge increase is because of how easy it is to measure. It's measured through short and effortless resting brain scans and EEG, and they can be done on any population, from young children to clinical populations to even non-human primates. Before we get into the roles and associations of the default mode network, I'd like to go over the brain areas that are involved in this network. There are three primary functional hubs, the first being the medial prefrontal cortex, and this is involved in the self-processing of personal information, such as autobiographical memories, future goals and events, and decision-making involving those very close to one, such as family. The central core of the default mode network is something called the posterior cingulate cortex, and this is very active in all tasks related to the DMN. It plays a role in combining attention with memory and perception, and it displays intense activity whenever you successfully retrieve an autobiographical memory. And this is also believed to be a mediator between emotion and memory. So it supports the idea that this is the thing that attributes emotional salience to autobiographical memories. The third functional hub is the angular gyrus. This brain area has several functions ranging from perception, attention, spatial cognition, and episodic memory, but it primarily focuses on complex language functions. Most specifically, the interpretation of and the making meaning of visually perceived words. It's also believed to be one of the main structures involved in the internal monologue and for understanding metaphors. In addition, there are two subsystems of the default mode network, the first being the dorsal medial subsystem, which is involved in thinking about others and socially directed thinking, and the medial temporal subsystem, which further supports autobiographical memories and simulations of the future. I have listed here all the roles and associations that are involved with the default mode network. I'd love to be able to go over all these, but for the sake of time, I'll just have to show this briefly. But a cursory look at this can kind of show you how, it can give you a good idea of the scope of the responsibility of this network and how there's an overarching theme in the relation to the self and how the self relates to the outside world. Developmentally, the default mode network seems to be something that comes into development during adolescence. We can see this because regions in the default mode network are only loosely connected in children, but they're strongly connected in adults, most particularly between the front parts of the network and the back parts. This makes sense when you view this network as being the neurological basis of self, because adolescence is a period where identity formation plays a big part. The default mode network has also been found in multiple species of animals. As of right now, we found the default mode network to be present in chimpanzees, in macaque monkeys, and in mice and rats. And the phenomenon from the previous slide, where the front portions of the network and the back portions have been found in the rat models as well, which is also interesting to note. The default mode network has also been found to be related to the perception of beauty. There's been found to be activation in a generalized way to aesthetically moving pieces such as artworks, landscapes, and architecture. This makes sense because of the deep inner feeling of pleasure most people report when they are in contact with aesthetically moving pieces, as well as people reporting it being kind of interconnected with their idea of yourself. Another interesting aspect of the default mode network is the role it plays in story comprehension. When multiple people watch a movie, listen to a story, or read a story together, their default mode networks are highly correlated with one another. They're not correlated if the stories are scrambled or in a language that a person does not understand, but they are if the same story is presented to different people in different languages. This supports the idea that this is part of the story comprehension aspect and not some auditory or language aspect. I like this picture. These parts in yellow are the functional hubs of the network, and these lines that kind of connect them are the connections between the functional hubs and how they branch out. I show this picture because it's a good illustration about what I'm going to be talking about next, and how dysfunction within these hubs and these connections can lead and be underlying in various psychiatric disorders. There's a lot that it plays a role in. There wasn't some I wasn't able to include, such as ADHD and schizophrenia, amongst others, but I do have a few that I'd like to share with you. The first being major depressive disorder, where there seems to be an overactivation and a hyperconnectivity between these functional hubs. This has been associated with rumination, which is kind of repetitive thinking and dwelling on negative thoughts. That is believed to kind of causes overactivation of this network. And this hyperconnectivity can kind of alter your perception of how you view the world, your social and your moral reasoning, and can leave you more vulnerable to depressive symptoms. This is also linked with one of the most common comorbidities with major depressive disorder, and that being substance use disorder. There seems to be large DMN activation in drug craving and withdrawal, but suppression in activity whenever there is substance consumption. Lost my train of thought. So failure to suppress this network can lead to an increased error in cognitive tasks, especially involving inhibitory control, and can interfere with goal-directed behavior. On the other end of the spectrum, we have conditions that are underactive and underconnected. Individuals who've experienced long-term trauma, such as childhood abuse or neglect, show worse connections between these functional hubs. People with PTSD show lower activity in the posterior cingulate cortex, and people with severe PTSD show an overall lower connectivity in general. A similar disruption can be found in individuals with autism. These individuals struggle with social interactions and communication, which are tasks that are central to this network, and most particularly between the medial prefrontal cortex and the posterior cingulate gyrus. And it seems that the more severe the autism is, the less connected these hubs are to one another. When it comes to Alzheimer's, there seems to be an issue of energy, and these disruptions can actually be seen before any other symptoms of Alzheimer's appear. There is a reduction in glucose within the functional hubs, which is kind of an energy source for the brain. So the high metabolic activity of this network, paired with a constant continuous activity, can cause a buildup of amyloid beta peptide, which is the cause of Alzheimer's, within the functional hubs of this network, kind of leading to a looser grasp of your sense of self. Now, there's a lot of directions that are going in this network, and I'd just like to share a couple with you. The first being the therapeutic use of psychedelic substances. Psychedelic-assisted therapy is something that's been in the works for a couple of years now, and it's been used to treat some debilitating conditions such as major depressive disorder, post-traumatic stress disorder, OCD, amongst many others. And the results of this research have been profound, to say the least, with many patients appearing to be in remission for up to a year or more. But what does this have to do with the DMN? Well, the DMN is suppressed immensely during psychedelic-assisted therapy. the connectivity in the rest of the brain increases though. This kind of enables a state of unconstrained cognition and is been associated with things like ego dissolution and increased brain entropy to get one out of their entrenched ways of thinking, and an overall improved mental health and well-being. The next part is the triple network model, where the DMN is actually just one of 3 networks involved in something, and the way that we use our attention to guide ourselves in our world, alongside the previously mentioned central executive network and the salience network. If you would like to find out more about this, I am going to be presenting a poster on this after the first round of oral sessions, and I'll be happy to answer any questions and teach you more about it. So to wrap up, there's been many revelations in modern medicine within the recent decades, and the default mode network is one of them. What we already know about the default mode network has already been used to treat intense conditions such as major depressive disorder and PTSD. And the role that we're finding it plays in the triple network model is holding a lot of promising insights and opening new doors to better treatments and better quality of life. Without these structures that make up this network, we wouldn't be able to reflect on ourselves, on our past, plot our futures, or even remember intimate details about one another. And that is why I've subtitled this network as being the potential basis for the neurological self.
We have a couple minutes for questions.
Yeah.
Any questions?
Yes?
Yeah, I thought it was very interesting, thank you. And I actually was wondering about the ADHD and you mentioned it. So an individual that have ADHD, this network is more active, is that correct?
It seems to be in a similar vein as autism, where it's the functional hubs are less connected to one another. So, but I think that's between the angular gyrus and the posterior cingulate cortex, where those connections are looser.
So are there activities that individuals can do to help promote more connectivity for this at a younger age, or does that plasticity increase?
Well, like I had mentioned, adolescence is a critical period for this the development of this network. So if you wanted to kind of nip it in the bud, adolescence would be a good period to teach good habits that would promote attention sustaining behaviors.
So how does this work with the dopamine theory of psychosis?
I'm actually unsure. I didn't see much of that in my research,
Okay.
but when you say the dopamine theory,
An overabundance of dopamine is what causes psychotic episodes.
yeah,
I mean, that's the theory, but this network could have a different connectivity too,
Yeah.
or behave different, or.
and I would suspect that it would be kind of closer to an overactivation of this network, so much so that it becomes like too much.
All right, thank you. Okay, so next up.